Welcome. This is the first video about numerical summaries. So in this sequence of videos, we'll discuss numbers that summarize a data set. And so we'll start with means and medians, or the measures of center, and then we'll discuss measures of spread, including the range and the standard deviation. The sections of the book are 15.2 and 15.3. You should still read those sections because there's more in the book than there is just in these videos. But the major goals are going to be to interpret numbers that offer summary information about the center of a distribution and about the spread of a distribution. So from the videos in regards to histograms, we discussed what a distribution was, which was just a list of numbers, more or less, about one. I mean, that's all it was a list of numbers. And the numbers represented a single numerical variable. So heights of people is an easy one to return to in your mind as an example. There's a distribution of heights of people. Some people are taller, some people are shorter. And then you have the center, the middle range, where most people are around. But somehow we want to have a number that will describe the spread of heights in a group of people. Okay, so let's move on. The first measure of center that we're going to discuss is just the average. And so the average is also called the mean sometimes. And it is a number that you arrive at through a rote calculation. You add up you sum all the values that you have in your distribution, and then you divide by the total number of values. So you count them all up. So our example we're going to run with for a bit is hours you slept in a week. So if over the course of 1 week, a Sunday to Saturday week, these are the number of hours that you slept per night, that list of numbers is the distribution. And you note that 8 is in there twice. That's fine. Repeats are fine. And we can organize those into a table like we do here, just for simplicity. And the mean or average for these numbers right here is attained or calculated by first adding up all the numbers in the list. So that's the numerator, is we're just adding them all up, and then dividing by 7, because there's 7. This 7 on the denominator is because there's 7 days in a week. This 7 over here is because on Saturday you slept for 7 hours. So when you add up all those numbers, so we can just do that in a calculator. 8 plus 8 plus 8.5, 6 and 9 and 7.5, and 7 equals 54. Equals 54 divided by 7, 7.7. And we can be happy with one decimal place, because 1/100th of an hour is really not all that much. All right, so that's you calculating an average. And then this next remark here says that an average tells you how you should evenly divide up a total so that every unit will have the same amount. So in our example above, that would mean having the same number of hours slept over the course of the week if we slept 7.7 hours per night. So we can write that. Or yeah, if you sleep 7.7 hours per night, then over the week you get the same total amount of sleep. Total number of hours. And we can just also give ourselves a little picture here. It's like if you had blocks of different sizes and you were adding them all up, the average is representing, okay, how big of a block do you need so that all the blocks are the same size, but the total amount of area is the same. So on the left, these would be like the individual elements of the distribution. Whereas over here, this would be what you might consider the average value. So that is the typical mean. There's also what we have is something called a weighted average. So in the above calculation, each measurement is given an equal weight. So each value of hours slept is kind of worth the same amount. When you calculate a weighted average, the different values have different weights. So imagine you're in a class which has a grading scheme that looks like this. So your participation is worth 10%, homework is 25%, your exams are 50%, and your project is worth 15%. So exams are twice as valuable as homework. Is something you might say. So let's just calculate your grade if this is you. You're always in class and participating, so you get all the points for participation. So you earn 100% for participation. You got a 91% on your homework. So, like, if you average the scores of all of your homework, you got 91%. Let's say there were a couple exams, and your average on those exams was an 86%. And your project, there's just one project, but you got a 95. Yeah. So the weighted average is your final score. And we can translate this table. So weights. The participation is worth 10%. The homework is worth 25%. Exams are worth 50%. And the project is worth 15%. You can note that these add up to 100. Add to 100%. That's just different than the items on the left, which were out of 100%. And the way this is going to work is we're going to multiply what you earned by its associated weight. So we'll have 100%, and we'll multiply that weight as a decimal. Because remember, percents represent part of a whole. And so that's why the weights add up to 100%. And in order to use the percent, you need to convert it back into a proportion. .25 is the 25% weight on the homework. The 86% is what you got on the exam, or on average, but they're worth 50%. And then the final thing was your project, which you got a 95% on, and that contributed, or that was weighted at 15%. So notice I haven't changed the earnings to decimals because we're going to calculate our final grade in terms of an percent. So let's add those numbers up. Let's go to the next line here. So we'll do 100 times 0.1 plus 91 times 0.25 plus 86 times 0.5. That's the 50% one. It's the exams. And 95 is what you got on the project, which was worth 15% of grade. So you got an even 90%. Equals 90%. So you get an A. Good for you. And that is a weighted average distinct from kind of the typical average. And a typical average where everything is weighted the same, all of the weights would be 25%. All right, so that's a bit of notes on averages. and I'll see you in the next video.